Sir, shall we start? Ganesan sir, can you hear me?
Hello, can you all hear me?
Yes sir, we can.
Okay, can we get the session started, please?
Yes sir, we can start now sir. Like we may start with the intro.
Okay,
Yeah.
I'm going to be presenting
Uh,
the.
sir, we have an introduction. Then you may proceed sir.
Oh, okay. Go ahead,
Yeah.
please.
Yeah. Once again, good evening to all the participants and welcome you all for the sessions 2 of this adult sponsored 6 days online FTP on next generation medical automation, the role of AI and IoMT in transforming the healthcare systems. We are grateful to welcome a leader whose insights encourage us to think, reflect, and innovate. I am saying about the person who is none other than our today's resource person, Mr. Ganeshan Narayanaswamy, founder and CEO, Object Automation System Solution, California, US. Before going to session, let me see the short intro about his success. He has completed his master's in computer science in 1995 from Alagappa Chettiar College of Engineering and Technology. He has more than 29 years of experience in both academic as well as industry. Ganeshan Narayanaswamy is a global leader for academia and research and distinguished lecturer in California. He is a founder and investor in technology business. As a senior leader at IBM for almost 2.5 decades, Ganeshan is well known for his contributions to chip design, artificial intelligence, and high performance computing. He has been leading the WW Academia term for open power chip to solution stack and organizing the development of that open power ecosystem, which including developing AI, ML, and cloud solutions, establishing centers of excellence for AI and chip design labels, industry hubs, and technology labs, among other things. Ganesan is always enthusiastic about collaborating on the development of creative solutions utilizing cutting edge technology with industries, partners, universities, and research institutes. Additionally, he created specialized courses and curriculum with special hardware access for chip design and data science AI. Now, I'd like to hand over the sessions to Mr. Ganesh Narayan sir, who is going to handle the session the topic of ML for design of chips and devices in robots using open source. Please, sir.
Are you able to see my slide deck?
Yes, sir, it's visible.
Okay, thank you. Just give me a second, actually. I don't know what's happening.
Yes, sir, yes, sir.
Yeah, I'm trouble viewing this. Oh, yeah. Okay, team. I see there are several people joined the FDP, and I hope the discussion what I'm going to have for next uh, 90 plus minutes, going to be very useful for all the participants across India. Hopefully, you will get to use our tools, for your special purpose, AI based. uh, the application building. So as part of my the workshop, the talk, I have chosen kind of as topic which is actually going to be useful for many industries. And you guys know that, like, next 10 to 20 years, the revolution is going to happen mostly in uh, in the AI based the technology only. And that is where, like, we are in. When you talk about AI is not just the software. It is, it has got its own hardware too. Without hardware, the AI cannot do anything. You guys should be knowing about that. Like, for example, like, supposing, you if you want to do a you have a data, and um, data is good. Always, the data is very important, but without processing the data, you can't do anything. So for that, you need AI kind of programs to do that. That will make the data more effective and efficient. And that is where the hardware comes in here. To process the data, you need hardware, and that hardware could be kind of the special hardwares and special purpose hardware, and many other areas where that hardware can be applied to. So and that's what we are going to spend some good amount of time around that. And before getting into this the special purpose, the AI IoT stuff, I'm going to be talking about open power. What is open power? How many of you know the open power in this group? This is actually developed and invented by IBM in 2013 time frame as part of the Open Power Foundation, where IBM and companies like Nvidia and Mellanox and a few other companies put together a consortium called Open Power Foundation, and basically submitted several uh, the open source based technologies which could be used by many people to develop new hardware, new software on top of that. And that's how the open power got evolved. And when you say the open power, everyone will ask so many questions on what is open here, and why it is very important and all the stuff. Before getting into that, I'm going to be spending some time on this particular slide. This is a very important slide for for today's world. Hold on, I think. Yeah, this is basically a kind of a the value chain for a AI ecosystem completely. This has got basically a design of a processor. Uh, the core, the designing of a processor, in the sense I'm talking about a real the CPU, central processing unit, or real computer, where it is getting done. This is where the design happens in the left side of the chart. What are all the companies leading in designing the processor, or co-designing? When you talk about co-design, they basically they don't do a full design for themselves. Basically, they work with a company who needs that kind of a design services. Some companies may not want to start their own design services, so they approach these kind of companies, kind of the partnering with other people. So Broadcom and Marvel, these are all the two major companies in United States, work on co-designing the processors and all those stuff. Who recently reached them out for co-designing the processor. That's one of them is actually OpenAI. You guys should be knowing about OpenAI very much because of the ChatGPT introduction. So that company is working with Broadcom to build the new set of processor for specifically to perform some of the activities as part of the AI related Gen AI related services to ChatGPT. And that's where, like, The Broadcom is leading in the market too, along with the Marvel. That's another competitor for Broadcom, who is also doing very good, in the co-designing services. Similarly, chip designer. These are all the traditional companies. Some of the companies, you must be knowing very well. Traditional companies, Intel, AMD, IBM is part of that, but IBM is actually, does everything. It's not just uh, designing only the processor, but they are into everything, and that's why it's not mentioned here. So the chip designers, significantly, spend a lot of money on this. Now, recently, the AWS, Nvidia, and Microsoft and Google have become very popular. The traditional companies are Intel and AMD for designing, the chip. You must be knowing, the Intel Inside. That's a chip. You have been building and buying it, for the last several decades. But AWS, why they want to do it? Why Google want to do it? Why Nvidia got into this platform? Why Microsoft? So the first, AWS, Google, and Microsoft. These are all, kind of, uh, people, who basically came up very recently, last 10 years, captured the market in the name of cloud. And behind the scene, they all need hardware. They all need CPU. What they thought, it's better to build their own chip instead of, using Intel chip or using Broadcom kind of services to design a chip. Because they have, enough money to go and build a chip too. And that's why, they are very popular now. They're all building, their own chip right now. And especially Google. Uh, they created something called Tensor Processing Unit, TPU, which has become recently very popular to process the matrix multiplication very quickly. And that's where the Google is, really, a good competitor for ChatGPT. The Google Gemini 3 has proved that the performance is much better than uh, much better than the chat gpt kind of the tool, whatever people widely use it in today's market. And also similarly, Microsoft, they are also like the cloud service provider, the big time. AWS, the big time, but they're also, they also want to have their own the chip design with AI features and all the stuff, and they are doing it too. Okay, so why Nvidia? Why what happened to Nvidia? See here in 2013, they worked with the Open Power Foundation to create this foundation and all the stuff. And that time, nobody would have known, Nvidia is doing, great in the, the accelerator business. The accelerator is nothing but, the graphics cards. That's what, they were initially making it. And now, Nvidia has been, leading in the market, providing, the AI accelerators, that GPU cards, the powerful cards, people buying it to process, the a huge number of huge amount of data. And that's how, Nvidia, GPU cards are sold heavily, in all 200 plus countries for, accelerating their data and, getting a result, out of that. And that's where Nvidia is actually very powerful in today's world. Uh, I hope you guys know all these companies very well, and certainly, all these companies are leading also, like $1 trillion business. Mostly, AWS, Microsoft, Nvidia, and Google are already captured, and they want to capture more and more, the market opportunities in the world. And that is actually the, the predominant side of, the Nvidia, Google, and AWS and Microsoft. Like, take a look at all those innovations, what they are doing as part of the cloud, as part of the background, the back end, the data center, and the systems and all the stuff. with the the GPU capabilities and all. Let me pause here. Any questions on this? These are all very important for building milestone with the tool whatever I'm going to talk about here. Okay, if not, I'll move on. So the EDA and IP. What is EDA? What is IP? EDA is nothing but electronic design automation. That's a very the standard one for the last few decades, where Synopsys, Cadence, and Siemens are the leading companies who basically provide EDA tools. The EDA tools very well. And the EDA tool is basically synthesizing your, the processing idea, whatever idea you put together in a code, it will do the synthesizing and make the code to be ready for fabrication. That means what? The making your own the CPU code, a processor, what you want to do, what it wants you to do, that kind of a uh, the code, it will basically make sure what kind of a performance it is going to work on, and what kind of a power it is going to work on, and what kind of a space, the placement, the routing and all stuff, it will take care. And that kind of the platform it provides. And these are all the three companies, top companies, who are doing that. Even Mental Graphics is one of them. Like that, so many companies are there. But what I'm going to address as part of this meeting is actually Open Road. It's an open source tool, but these are all commercial tools. Whatever you need to pay millions of dollars, to make a before EDA tools, for fabrication and all the stuff. And then IP. What is IP? It's nothing but intellectual property. See, if you want to make a particular processor or something, you need to build a complete SoC, a system on a chip kind of a capability. So you may have an idea, to make a processor, but what about the peripherals, for that processor? Like peripherals could be like, your Wi-Fi, your USB interface, and your other interfaces to your processor. All those stuff, you may need to procure, or you special functions, if you want special functions to be incorporated, which is already patented by someone. You have to pay the IP money, intellectual property money, and that's what it comes from. So ARM is actually one of the key companies, right now. You can use ARM, the IP core, the special purpose SoC, for building your own processor to attach your own ideas along with ARM and build a kind of the overall system. And that is what ARM is leading that. And then Synopsys also has got some special IPs which you can buy and you can build and incorporate that feature as part of your processor building. And then Cadence, there is also another company. So these are all the companies, which is listed on the left side of the chart, is actually making design or a co-design of the processor. Okay, so let me move on. And the other, the middle, in the middle of the chart, that's actually the companies who basically produce, the fabricate your idea to a chip. And that is where, like, the real fabrication happens, the chip manufacturing happens. As far as India is concerned, there is no the fabrication company which is producing the latest the size of the chip. The latest size of the chip is right now 2 nanometer size, and 5 nanometer and 7 nanometer and 14 nanometer kind of a size, it ranges from. But what India has got the capability right now, 130 and one, I think 180 nanometer, not even 130, 180 nanometer. That is too huge for you to put it in a edge device kind of a stuff. Whatever we are talking about AI, OT, and we need the 2 nanometer size. Is basically found by IBM. Sometime 5 years ago, working with Albany, the state of New York, in Albany Center, where the innovators found that technology, and basically they are also building the chip, with the help of Japan government, and also there is a partnership established with Japan, and they basically formed a company called Rapidus, and they are working to produce that the chip to the 2 nanometer chip that is basically a nail sized chip, and that kind of a feature is going to be helpful for low power, because when the chip size is very low, very very small, the power usage also will be very less, and also that can fit into your edge compute very well, and also smartphones and all very well. And that is where the industry right now leading. But right now in India we don't have such a fabrication unit. And these are all the companies who basically make equipments, and then the foundries to make the real chip, like, and then packaging after the chip is done. We need to package it in such a way that how small, I mean, what are all the bits and pieces of the chip feature you want, and all the stuff um, need to be developed too. And you see here all these companies, several companies do work on fabricating the chip. But you may find some companies there in Bangalore and Hyderabad and Chennai. But these companies actually, they don't have a fabrication unit. They may have a back office where some engineers work on developing some ideas for future equipment, or the future packaging technology and other stuff. But actual a platform to create the chip not there in India. That requires billions of dollars investment. And still companies or Indian government not ready yet completely for that. But I think if I remember correctly, in Assam, Indian government, in partnership with Tata, they created something, but nothing has come out so far. And until we get some real chip, we are not going to be in that business or in the market. Okay, and that's where we talk about here. And then this year we talked about design, we talked about manufacturing. Oh, once you have a design, you'll give the design to the manufacturer, and you'll have a chip, right? Chip is going to be in the form of what? And that's what the third the column says, that chip is going to be in the form of GPU or ASIC or inference or edge. And as I said before, edge compute, the topic related to today, AI, OT, that's going to be playing a key role in the edge compute, where billions of edge devices we need for the next 10 to 20 years, with the different technology, different ideas, different features, and all the stuff. And that's where all these market opportunities are all growing. And I know that, like, you need data centers to build your model to be trained. And only one time you need to train the model, one time in the sense once in a while. But edge compute, where you need edge devices everywhere at your at your place. It may be at home, it may be at road, or it may be at your office, or in the car. You see, one example is autonomous, the car, where the driverless car. We don't need a car, for driver. In future, it's going to be, in India too. It's not ready yet, but here we have a driverless car already running in US, in top cities, where there is no driver. The car will take you to anywhere, based on your app, the input and output. And that's how this has been going on. The industry already trending with the the edge compute kind of a interface. And suddenly AWS, Google, began the scene on this driverless car already. And then even Tesla is now jumping in on the driverless car, all where the taxis are all, like, going to be operated using that feature. Any questions on this slide deck? This is a very important one. And if you know all these things,
May
everywhere,
I?
hardware and software is going to happen like, with this only, with this stack. Hello?
Yes, sir. May I?
Yeah, go
It's
ahead.
Am I, am I audible, sir?
Yeah,
audible,
yeah,
So,
audible.
you're
so
audible.
actually, the moment when we speak about the ASML, so I hear somewhere, so we had a extension of this ASML in the part of India, and we are investing, and they are expanding towards India, particularly in Gujarat. But I'm not pretty sure because I was very fond of this ASML, and I'm looking at this trends, how this ASML is growing very fast in recent times to the peak. Maybe in future. So my question, sir, if it has been expanding, like I hear expanding in India, is that true? If so, what will be the major area they are focusing to incorporate with this technology?
No, no, say it again. It is not clear. Maybe the audio is not clear. Can you repeat again your question?
So I hear ASML has been extending their services in the India, so maybe in the Gujarat. Is that so true, or is maybe a fabricated resource? Or and my second question is, if so, they are expanding. Can you please elaborate a trend they will expand in India? What is the probability they focus on? And speaking about ASML, sir.
Yeah, ASML, is one of the key companies, even in San Diego, where I live, their offices. And, I think they have a, headquarter also, like, headquartered in San Diego only, in our city. Yeah. Definitely, the ASMR, do have a customer support office in Gift City in Gujarat, in Ahmedabad, um, in basically, they are actually into, the manufacturing the wafer equipment. That's, right, the wafer is actually important for, making a chip. And, that is where, like, they want to get in. But actually, the wafer and all, like, when you do, like, you need to be doing a lot of designing on that, not the actual development, but the designing of the wafer, the future wafer. The wafer could change, based on the even the node size. I'm talking about the chip size. And there are a lot of, AI technologies applied to it, and create the future, the wafer equipment and all the stuff. And certainly, yeah, as you asked, in Gujarat it's expanding because, Indian government is actually, what do you call, the due to geopolitics and geographic advantages, there are some certain cities, will have geographic advantages. But there are some cities, have advantage of geopolitics. And I don't want to add more things into it, but this is all geo related stuff. And yes, in Gujarat, Indian government planning to expand a lot in, many areas, and that's what going to happen continuously. I hope I answered your question. And the ASML, yes, definitely the wafer equipment, is very important uh, for your, the chip to be developed, manufactured. And future designing of wafer has got a lot of, R&Ds and all those capabilities, will be developed in, in one of the places in India. That could be Gujarat too. Okay.
Thanks for answering, sir. Great.
Yeah. And it's basically, right now, the world is actually like a kind of, reachable everywhere. So you need not have to worry about, which location you're going to go and work. But it is actually always good to go and, just go do work there, because originally I'm from India, right? But I'm in San Diego. It's like that, everyone can go anywhere, and start working wherever the opportunity and wherever the growth thing. So that's how it all happens. So opportunities based, things, one can do it. Okay, so now let me move on. So, introduction to open power. I said before, we will be addressing the open power foundation. The open power, got created long back. So now you see that the page here, founded around IBM Open ISA. IBM Open Power ISA is nothing but an instruction set architecture. So for you to make a processor, you need a set of instructions, and standards. And that's what the ISA, and that ISA is open through Open Power Foundation. So that means what? It's open source, freely available. People can take a look at it and see what is there, and and also it's a royalty free. You don't need to pay any money for that. Whereas if you go and use the arm, the thing, you need to pay money for that, and that's a different set. And that's why the arm is basically kind of is a kind of a paid IP, kind of a service provider. Okay, and enables chip innovation across edge, cloud, and robotics. So you saw that here, chip innovation. So edge means what? It's basically kind of a edge compute and a cloud and robotics, and supported by IBM, Nvidia, Google, Object Automation. A lot of few companies are partnering with Open Power Foundation. There are like a 200 plus partners are there, and even educational institutes. Nearly, I would say 300 plus education institutes are part of Open Power Foundation. Engage with us. I welcome all of you to be part of Open Power Foundation. We do have a Slack channel where you can join, and every day you can learn about new things, and there will be free seminars, and the collaborative opportunities, and also access to hardware for both the AI hardware as well as the EDA tool, and also the FPGA kind of a devices where you can prototype your ideas into it before even getting into manufacturing and all. You can prototype your the chip idea. All these things are available through the Open Power Foundation. And also the Open Power Foundation facilitates to set up a center of excellence. Already, like there are like a 25 center of excellence worldwide, including in India, US, and Europe. And you are all welcome to reach out and let me know, so that we can discuss about the center of excellence, possibilities too. That will have your own hardware, your own solution, and educational system. The complete is basically the tech enablement and tech development and tech research. All three things can happen as part of Open Power Foundation. So that's why the focus on open hardware plus AI acceleration plus education, and that's the beauty of it. And let me know if you have any questions on this slide. And then ecosystem. When you talk about ecosystem, it's basically IBM, Red Hat, NVIDIA, Object Automation, eFabless, universities are all part of Open Power Foundation. The and membership around that, and building each and every component as part of as part from chip to solution, and focus on AI, ML, edge compute, cloud hardware, and open system on chip design. So what else you need as part of computing? Everything is there as part of the Open Power Foundation. Even you can simulate a quantum computing hardware using the power the open power hardware, and you can also run QSkit, the the platform whatever IBM produce. It runs very well on our open power hardware too. We put together recently some kind of a scenarios on that too. So, well, you are all welcome to explore, and see what you want to do as part of quantum, high performance computing, AI, and cloud. All these things, possible with the Open Power Foundation, and it's open, and open for collaboration, and certainly, people can educate, a lot of, educate the students, the faculties can get educated, and a lot of, collaborations can happen through this foundation. And yeah, this is the important slide here again, where I'm coming to the point here. AI IoT device, which you can build using this platform. So what is that? Microwatt. What is that? It's basically a kind of a the open sourced processor. You see here, Intel has got a CPU, right? And then AMD has got a CPU, right? And like that, similar to that, the Open Power Foundation has got a CPU. It's a soft core, a mini CPU, which is open sourced already. It's called Microwatt. So what does it mean? Yeah. So what does it mean? Um, this means you can prototype your own idea along with this microwatt code, and it's a free code. It's There is no IP, you need to pay for it. If it is from ARM, you need to pay for it, but it is free. You can take the microwatt code, you can make modification, and you can create an edge device based on your requirement, and that's where the microwatt has been written. So it's like a kind of a 25,000 VSDL code. You can take a look at it. You can Google microwatt and find out, and then it's a FPGA ready. What does it mean? You can go and flash it in a FPGA and boot the Linux attached to it also. We already have a booting establishment with Linux too. That also um, you can make it immediately. You don't need to spend a lot of time on that. And then minimal design for edge AI. That's where the key point here. So here you're talking about the edge IoT device, you can create yourself, and that's the feature of it. So that's one of the feature, the one of the key feature, which you all, can listen to it, and then see how you want to incorporate, as part of your college or university or anyway research ideas. And that's a story about the microwatt, and certainly we have some courses special courses available completely to learn about microwatt, walk through the microwatt, and basically how you can make the microwatt for chip development too. That also, like we have that are all, we will talk about it also a little bit here. And but if you want a complete course for the students, you can reach out, the open power through me. And A2I, A2O code. These are the cores IBM, I mean CPUs. A core is nothing but a CPU, a piece of CPU. So it's a multi-core used in IBM Blue Gene Q. That is actually A2I and A2O core. So what does it mean? Uh, that core is open source. It is available for you to look at it, and you can start working on it, and you can build your own the supercomputer also, like kind of a good server also, server class CPU also, with this A2O core. And that's why IBM open source that code also, where you can go and take a look and make modification to it, and appropriately you can use it for your own development. And LibreSock is another the version where a community is actually working on it with the CPU and GPU for special workloads like AI and vision and all. So that code is also available for you to take a look at it. And anytime you can search for this kind of a code in Google. You will certainly get your data. And you can also, you're welcome to join open power foundation, and join through our Slack, and reach out, all the developers who are part of uh, the code, whatever I'm talking about here. And then Chiselwatt is another microwatt kind of a platform, where it's basically added feature, so that it can handle a lot of low power situation for the edge. So that's also available. Take a look at it. These are all the four major things available as part of the open power, without any IP money. You don't need to pay any money to procure all these things, to work on all those things. Any questions on this very important slide? Because If you want to develop a AIoT device, these are all the tools. The platform would be very useful for you, and tomorrow you can start working on this. There are people in Chennai, in Bombay, and in IIT Patna, IIT Chennai also involved here, and there are some people from Goa and Bangalore. A lot of people put together. They're all using this to create platforms. Just want to tell you that. Okay. If you don't have any questions, let me. I'll move on. So the key features of OpenPower: the fully open RTL for customization, 64-bit RISC with multi-core SMP, high Linux compatibility, supports ML accelerator via OpenCAPI NVLink, ideal for FPGA, ASIC and SoC prototyping. So, what does it mean? I hope you guys know about this. Full open RTL for customization. You know that, right? We talked about RTL. When you want to develop a CPU, you need to develop a RTL code. You have to develop a VHDL or a Verigar based a code for particular operation. Whatever you want to do, you need to put it there. And here in my whatever we talked about, microwatt or A2O or A2I core or Chisel Vault or Libersock, all these things are all open source, already available for you. RTL code, all you need to do is some customization you need to do such a way that you can use that for your own purpose. And that is where the open power is very important for education purpose. People can get educated very quickly on on the technology whatever we are talking about here for next 10 years. And then 64-bit RISC with a multi-core SMP. See here, this is a 64-bit RISC-based processor. It's not a RISC-V. It's a RISC-based, RISC architecture. We have CISC and RISC architecture, right? It's a reduced instruction set, computing, and with multi-core SMP, symmetric multiprocessor. That means what? Not just the one core. There are more than one core. You can have in 1 microwatt code, and that is what it is representing. And then I Linux compatibility. I told you already, with a microwatt you can boot a Linux. So that means what? It's basically it supports Linux already, and you can boot the Linux. And that's a feature of the open power, the code whatever available, and supports ML accelerators via OpenCAPI and NVLink. So there is another feature which we added as part of that too, where if you want to basically accelerate with additional capabilities, this can be already, like, we can plug in with the OpenCAPI kind of interface or NVLink kind of interface. And then ideal for FPGA, ASIC and SoC prototyping. So yeah, obviously we talked about that also. The system on a chip or ASIC, directly you can make a ASIC a chip, and then FPGA, field programmable graphics array. And where you don't need to fabricate a real chip for your prototyping. You can use FPGA for prototyping and do all the testing before fabrication. That's how it is. Any questions? All these features are very important for you to develop a AIoT device with hardware and software and everything. Any questions, team? Okay, I'll move on. So why ML in chip design? See here, we talked about code designing a chip design, and then manufacturing a chip, and chip in the form of inferencing device or a edge device or actual GPU or a CPU. And we talked about you know what is available in the open source world. ML chip, I mean, sorry, the open source world, we talked about microwatt, we talked about A2O, A2I core, we talked about Chisel watt, and we talked about Libersock. All these things are available in the form of open source, where you can pick up the code and with a little customization, you can start building a edge device. But now uh, we are going to talk about, ML in chip design, machine learning, AI. The AIoT, that A stands for, AI stands for artificial intelligence. ML is one of the key features there. So, traditional EDA is a rule-based iterative. The EDA tool we talked about, like basically the one, whatever commercially available, Cadence, Synopsys, and Siemens. But here, all this, the traditional EDAs, it's a rule based and iterative. It's basically kind of a serial stuff. ML brings, predictive modeling, RL for floor planning, kind of, the special, things, for, the EDA related, task, it can be done very quickly. And that's what, the predictive modeling and RL for floor planning kind of a thing, it has got. And then generative AI for RTL synthesis. I said right before, you need to do a fabrication, you need to synthesize it, with certain, parameters, and those things, can be done using, the generative AI kind of, feature which you can incorporate. And that's where, we will be using, kind of a open source based, the EDA tool, in order to, understand more about it also. And then faster, smarter, and more efficient design closure. So that means what? You can close the design, very quickly, instead of waiting for 6 months period or 3 months period, because you are applying AI features here, so that you can find out, there are a lot of errors initially, in initial days only, before even getting into the major issues, once you fabricate a chip. Any questions on this? So here we are talking about here multiple things. In the EDA side, also the ML can be used, and the generative. I mean, RTL side also, like, RTL synthesis also. The AI can be used, and definitely a design closure can happen very quickly with all these, features, like a fast, the fast, smart, and more efficient. ML chip in ML in a chip design flow. This is another important thing, which you all need to learn. Certainly, the ML can be applied in chip architecture. ML explores design space, and then synthesis, regression predicts, the PPA, and then floor planning and deep RL for layouts, and then verification, ML guided, the coverage, and ML predicts hotspots. So all this stuff, very important. All these things, can be applied quickly, using, the ML here. And ML in, the machine learning, we are talking about ML because that's a basic of, the foundation of, the AI. And ML in edge device development. ML optimizes chip design parameters, lightweight ML for open power SoCs, predictive reliability analytics, and integrating AI co-processor with open power cores. All these things can be, like, can be developed as part of, your edge device development. Okay, let me move on. Open power in robotic hardware stack. What does it mean? So here I'm, I'm actually putting together a kind of a AOT device, AIoT device, which you can develop using the, the platform what is available through Open Power Foundation. The the robotic hardware stack, what all it has got, it has got, and how one can build, those things, perception is one of the first thing, which one has to, look at it. Vision sensor for fusion with AI, and then control, RL based motion control, planning, policy learning using multi-core, and safety, ML for anomaly detection, communication, ML based data optimization. All this, the five, the flow is very important for robotic hardware stack: perception, control, planning, safety, and communication. So what does it mean? The if you want to build a real the robo is you can start working with Open Power Foundation. You can start using some of our already available code, where you can customize it a little bit so that you can start building it. There are certain people working with us on this idea too, and that's how I'm presenting it here, as part of Open Power Foundation, as part of AIoT feature too. So ML enabled robotic devices, AI control chip, real time motion control, sensor fusion processor, lidar, radar, camera integration, and then smart servo controller, safety monitoring unit, ML based, the failure detection. All this stuff, being built, using the ML feature, as well as the microwatt kind of a code, where underneath, these are the platform people use to build it to. How one can build it is all like, you need to learn about what is in there, in the microwatt. I said about 25,000 lines code, right? That code also can be reviewed, and see what can be reused as part of the code, and what you can incorporate a new feature. And you need to basically make the code ready for us, like a fabrication using the EDA tool. It could be a commercial EDA tool like a Synopsys or Cadence, or there is a tool called Open Road. That is also like done by another community, spearheaded by one of the professors in UCSD, University of California, San Diego, and Andrew Kahn. And Andrew Kahn is a professor, and the Open Road is a EDA tool, which is available for free of cost. You can go and take a look at it. Now, recently they introduced a new node support, which is actually 55 nanometer. So what does it mean? You can synthesize the RTL code for 55 nanometers chip size, and you can get that fabricated using some of the foundries, but the platform is available for free of cost. So that's where you can learn more things about EDA tool too. So take a look at it and let me know what you think on that too. So industrial robots, so industrial IoTs, AI IoTs. What are all the things here? We are talking about predictive maintenance chip, AI edge controllers for automation, vision boards for defect detection, ML optimized energy efficient actuation. Like that, plenty of tools, plenty of robots people can develop, using the using this platform. So that I want to really mention here, because these are all things people look at it, when they want to basically develop a bot, a special bot, for the specific task to be done. And I think in next 10 years there will be several bots, people will be developing AI based bots. That's what the like a kind of a edge device, AI based edge device, will be there everywhere, at home or on the road. On the road already, like the AI based cars are available right now in top cities in US. And similar to that, there will be so many bots, will be yeah, utilized, in a commercial organization, as well as at home, in your residential place too, or in a residential complex too. So be get ready for kind of a innovative path, so that these are all the areas where people can develop more things, as a platform, and as a key feature, where you can also create your own IPs, with that. You can also apply for patent, adding a feature to it, and then apply for a patent too. A lot of research and development opportunities are there. Yeah, we talked about this very, little bit on, the autonomous car, the driverless car, which is getting very famous these days. Autonomous vehicles and drones, sensor fusion SoC with ML accelerator, AI vision processor for object tracking, oral route planning code, and battery optimization using predictive ML models. So all these things, already happening. And maybe in India, people in the behind the scene, they may be developing these things, but actually the autonomous, the cars, we are not seen in India yet. But here, in US already, there are plenty of cars. I think thousands of cars are running without a driver. So I just want to tell you that these are all the features added as part of that. And that's where, like, we are actually looking at it right now and see what else can be done as part of that autonomous vehicles and drones. So service and humanoid robots. I hope you guys recently heard about this. Heard from CEO at Tesla. The Elon Musk, about robots. He's going to develop nearly 100,000 robots in next 10 years. And these are all the the robots will play a big role at home, even at your office, to do a lot of day-to-day operations. And that's all going to happen for sure. And we have tools and libraries already to make such a robot. And the emotion and voice processor using ML, the gesture interpretation with the tiny ML, local LLM brain for interaction, and adaptive motion controllers. All these things can be incorporated with the code, whatever I talked about, the microwatt or a chisel watt. The chisel watt, low, is very helpful for low power, and LibreSoc with kind of a GPU capabilities also. Any questions? Somebody was talking about it. Anybody is interested to develop a robot or a humanoid in next 5 years? A project which we can do together too. Okay. If not, let me move on. So, what are all the areas where the robots are going to be very popular in India, in the world? Surgical robots, precision AI co-processor, and then delivery robots, where all these delivery boys will be replaced by robots for sure. Like how AI is replacing a lot of service jobs, like that. In future, you may not see the Uber driver or something. Only robot will drive, deliver the food for you. And drone swarms, edge AI chip. The drone also will Amazon right now already trying with drone to deliver packages. So from the data center, I mean data warehouse, to the residential community, already that tryout is happening, and that will happen very soon too. And then companion robots, LLM based emotion processor. So all these things already being investigated and also being developed. And take a look at it, see where all, like, how you can apply your own thoughts to get on to these technologies. These are all very uh, good areas for you to develop even now. And there are tons of opportunities, as I said, tech enablement, tech research, and tech development. All three areas, one can get onto it and see what can be done. Even teaching, as a teacher, as a faculty, you can take up one area and go do put together kind of documents in that area, and start teaching the students and communities, building a new the surgical robot, or a delivery robot, or a drone with a lot of automation, applying AI, and companion robots. So all these things, can be done even in India. Any questions? Okay.
No, sir. Please continue, sir.
Yes, sir,
Okay.
I'm
Yeah.
having one thought.
Yeah. Please go ahead.
Sir, actually, I'm having the doubt about you have opened our eyes towards open power. But as a professor, now we are in a stage to develop our, that is, we have to understand the concepts. So you explained nicely about the concepts. Can you give any case study of how this can be applied, and what is the difference when we are doing a design by ordinary method and by using this open power? With the case study, can you explain, sir? Because we have applied the ML concept, all the latest AI techniques here. So we would like to say, understand with the help of a case study. Is it possible, sir? Now.
See, we can have a separate discussion about a case study, because there are, it takes a lot of time, even the case study can be done with a practical exposure too. We do have access to, a real code where we can show you the case study also. I mean, real code, how it works, how we can build, and how we can push that in a FPGA, and how we can boot the Linux with that feature. So that takes, right now, I think that's a process, we follow too. Please, do reach me out, and we can put
Sure,
together
sir.
a separate an hour discussion about, a walkthrough about a use case. Case study is nothing but a use case,
Yes,
and
sir.
a
Yes.
walkthrough on a use case we have, so we can do that too. I never heard that, like, in this FDP we have to do some practical demos. Otherwise, we could have been ready with that too. Okay,
Oh, fine,
so
fine.
reach me out on that. Definitely that's a good thing. That we have already so many case studies we have. We can walk you through
Ah,
a simple case study with the hardware, whatever I'm talking about here, is all available in
so
our
we are,
cloud.
okay, sir. Actually, we are very much attracted towards this open power. So we'd like to apply this knowledge to our students so that they can also develop surgical robots, especially in the field of biomedical. That's what I'm asking, sir. So we will have a separate discussion later, sir. Thank you so much.
Yeah, yeah. Thank you. I think it's a good question, and certainly, we will support this kind of initiative from the academics. Okay, sure.
Thank you, sir.
Any other questions, team? Okay, let's move on. FPGA and ASIC prototyping.
Excuse me, sir.
Microwatt synthesized on a RT7
Excuse me, sir.
uh, ZCU 104. You guys know,
Excuse me, sir.
the RT7 board, which is very popular, for you to basically, prototype some of the Raspberry Pi or a kind of, the Pi devices. Have you ever heard about RT7 board, the FPGA board from Xilinx, from AMD? Right now, AMD acquired Xilinx, so is AMD. Okay, so we do have access to those boards also for free of cost. Maybe if you reach me out, we can walk you through the board and how to use that, and how to basically bring up the board using the Xilinx tool, the famous tool called Vivado, and how to basically flash the microwatt code into it as a case study, and how to basically bring up a tiny Linux into that, and then you can boot the Linux on your own processor, and you can create, you can add some new instructions to the processor, and you can basically go and program that instruction in your program too. That kind of a feature also available as part of microwatt, whatever we are talking about here, and we will walk you through as part of a case study presentation later on, based on the request, for sure. And then ML co-processor for robotic inference, and ASIC tape out via Open Road and eFabless. So I said, right, the Open Road and eFabless. eFabless is another company, partner company from from Open Power, and they work with us, to take our a processor over, works with us for academic purpose for a tape out. Tape out means, you will get actual processor, in your hand, whatever features you you incorporated, based on that, it will work out. And rapid iteration from FPGA. So that's also another important, like, once you have a FPGA prototyped, a prototype, being implemented in a FPGA, you need to make a silicon, and that's how, all these, things, very quickly, will be very helpful. All these tools and libraries, to make your idea to a silicon. That's where the keyword, idea to silicon, how it happens. All these things, can happen using this platform, whatever we have been talking, the last 65 minutes, 70 minutes. Okay, so now research and capstone ideas. So there are a lot of ideas people have, and certainly we can support that kind of idea with our platform, whatever available, and with our the center of excellence, and several thousand people are involved in this partnership, and everyone can jump in and support your idea to a market kind of a thing, or idea to innovation, or idea to silicon. A silicon is a real chip, edge chip with some features added to the chip, so that that feature will help to provide the service whatever you wanted. So that kind of complete step by step process can be done using this. So anyway, if you have any ideas, do reach out to me, and certainly we can work on a plan to even sometimes uh, we can write a joint proposal to the governments, and get onto it too. So a neural accelerator integration, ML based workload profiling for robotics, NAS network attached storage for AGI SoCs, all this stuff can be done, and we can work as a team to make it happen too, based on your uh, requirement to it could be any industries, manufacturing industries, or healthcare, or retail, or transportation, or aerospace. All these industries where some of the ideas we can put together, we can jointly work on deploying that too. Any questions? Any ideas, like the Shobha madam mentioned about the surgical robot, like that? Any other um, thoughts you guys have?
Sir, good
Team?
evening.
Yeah.
Yeah. So how will it work on agriculture part, sir?
Oh yeah, certainly. I missed out to add that feature, like the feature in agriculture. Definitely, there are a lot of things can be applied in agriculture with the AI, IoT. I mean, with the
Okay, sir.
edge devices. Certainly, for the
Okay,
weather
sir.
prediction, for farmers, need a lot of tools and libraries, for these kind of devices, for them to operate it very quickly, and then they can, through the voice, the local language, they can converse, and they can get the work done through that, applying
Okay, sir.
uh, pesticides, and applying
Yeah.
kind of special things, liquids and all the stuff, using the drone. So many things can be deployed using this.
So okay, sir. They can learn
Yeah.
about even the soil fertility and
Yes.
humidity. Definitely, sir. Okay, sir. Thank you. Thank you so much, sir.
Yeah, agriculture is one of the key areas to. There are a lot of automation, required for that, so that you will get a very good, yield, out of your lands, whatever you spend on, and
Mhm.
also organic food you can get to.
Okay, sir.
That's good. Good question. Yeah.
Thank you.
Yep.
Thank you, sir. Yeah.
Any other thought process where maybe we can form a team, one can work on some specific areas in one industry, and come out with some kind of a plan and see what we can do together as part of the team, local, using what we have, as already we are providing a lot of things for free of cost, and you can add some of your ideas to market, and ideas to to make a silicon, and that kind of a feature can be done too. And
So can we have
certainly,
your?
yeah,
I'm sorry to.
go ahead, madam.
Sorry to cross this, sir. So can we have your email ID so that we can contact in for future? You're planning for any project.
Yeah, I'm going to share the, while talking only, I'm going to share in my chat window email and my
Okay,
number.
sir.
People can reach
Okay,
me
sir.
out, and this is going to be very
Okay.
useful for everyone.
Yes, sir. Thank you, sir.
Yeah, I'm sharing that right away.
Yes, sir, we got it. Thank you, sir.
Okay, so that's good. So we have two, three industries, people are interested in multiple opportunities. So the ecosystem and roadmap, that's what you're saying, yeah. How many of you know CDAC in India? Central for Development of Advanced Computing. That's funded by MeitY. MeitY is one of the key organization under IT department in central government. So the CDAC is located everywhere in India, most of the states. Mainly Bangalore and Pune are the main offices, and one in Trivandrum, which is also a big office. Chennai also they have a small office, but all this put together, there are a lot of innovation happening within the CDAC organization too. So you guys have to reach out to, and CDAC is putting together a supercomputing conference next week in December 9th, 10th, 11th in Bangalore. You're all welcome to be part of that. Reach me out. How do you want to be part of that? And maybe I can give you all the directions and details. And as part of that supercomputing conference, we are presenting three workshops. One is on Gen AI using open power, and the data engineering using open power, and the chip design using open power. The three workshops are happening, and also we do have keynote speakers from our the experts group, and also we have a booth on open power. You can anytime you can come and see the demos, real time demos. This is all happening in Bangalore between 9th to 13th. You are welcome to explore that too. And definitely you guys should know about CDAC, what they do, because government is investing a lot of money on educating all these key features, to each and every one in India. So that's there. And then as you see, our partners are the eFabless, IITs and NITs and all. And then roadmap, ML modeling, FPGA prototypes, ASIC tape out, and edge robots. All this, the kind of the flow in place as part of our collaboration. Any questions? Okay, so we're almost, yeah, see here, my email ID is also here. So impact and call to action. Democratize chip innovation for robotics or edge AI, enable AI at the edge, build a global open source robotic SoC, train next generation engineers, and join the Open Power ML Robotics Initiative as part of AIoT. And that's where you can reach us out using the website, as well as even when you look at the object automation website, you'll have a AI based bot available inside, to help you out, to browse through the details. So reach out on that and let me know if you have any questions on that too. Certainly, there are a lot of opportunities are there. One can build it with this. And our, we are headquartered in San Diego, California, and we have a development office in Chennai, in India. Any questions? So this is where I want to share some of the details, and some of the important keywords, and yeah, the important keywords from the talk or whatever I have presented, the microwatt, Chiselwatt, A2O, A2I core, and LibreSoc. You can look for the microwatt, the CPU core, the GitHub directory where we open sourced, and also openpowerfoundation.org where you can get more details on that, and then object-automation.com to get more details about tech, the enablement, tech development, and tech research related opportunities. And all these things would help to grow your students, college, universities, as well as the faculties over undertaking all these ideas into the market. Any questions? Anything you want to add here? Feel free to ask questions so that I can address it here. Okay. Uh, Organizer, if there is no question, I'm done with
Yes,
the
sir.
today's presentation. And yeah, always people can reach me out if they want any more things as part of this.
Dear participants, if you have any questions, kindly ask the resource person, or else we can wind up the session.
Okay, team.
Sir, I
Thank
think
you.
thank you very much,
Yeah,
sir, for your informative session.
thank you all, and looking forward to work with you all in more collaborative way. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Yeah, thank you all.
Thank you very much.
Thank you, sir.
Dear participants, session 2 feedback posted in the chat box. Kindly fill it out.